Overview. An analog pressurization system is fitted and operates by controlling the amount of air allowed to leave the pressure cabin through two discharge valves. This system is available to a maximum operating altitude of either 31,000 feet or 33,000 feet. The pressurization system is designed to maintain sea level pressure in the cabin up to 15,000 feet, with a maximum cabin altitude of 8,000 feet at 31,000 feet or 33,000 feet. Automatic protection facilities are available to control maximum cabin altitude, maximum cabin differential, and maximum negative pressure differential. Introduction. The pressurization control panel is located on the overhead panel and controls the discharge valves in both automatic and manual operating modes. Two standards are available: a maximum cruise altitude of 31,000 feet or 33,000 feet. The operating mode is selected by a mode switch and is normally set to auto. In automatic mode, the two discharge valves are controlled using the auto dial. This indicates selected cabin altitude and aircraft flight altitude at maximum differential pressure, and the selected barometric correction. On the ground, weight on wheels, the automatic mode fully opens both discharge valves. Control knobs below the dial allow cruise level selection and barometric correction. Cabin altitude, equivalent to cruise level at operating differential pressure, is displayed on the outer scale. Cabin rate of climb to the selected cabin altitude is controlled by the rate knob. A detent on the rate knob provides a normal operating climb and descent rate. The discharge valves are controlled automatically to maintain the selected cabin altitude. Their position is indicated on two separate gauges. A triple gauge indicates rate of change of cabin altitude in thousands of feet per minute. Differential pressure between cabin pressure and outside ambient pressure in pounds per square inch. Cabin altitude in thousands of feet. Under manual operation, the discharge valve position is controlled directly by the manual rotary control to open or close the discharge valves. This control is only active when manual is the selected mode. Under manual or automatic operation, the pressurization controller electrically signals the discharge valves, which are then pneumatically actuated. In either automatic or manual mode, each discharge valve can be controlled independently, using a control switch to enable selection of the following control modes. Normal. The switch is detented in this position. Shut 1 or shut 2 signals either discharge valve fully closed.
Ditch is used to depressurize the aircraft or when landing on water. In this case, water ingestion into the outflow valves will hold them closed, preventing further water ingestion.
Each discharge valve provides protection against negative cabin differential pressure, which is limited to 0.5 psi. Cabin altitude, which is limited to 15,000 feet. Excessive cabin differential pressure. For the 31,000 feet version, cabin differential pressure is controlled to 6.55 psi up to 29,000 feet and 6.75 psi between 29,000 feet and 31,000 feet. In the 33,000 feet version, maximum cabin differential pressure is controlled to 7.17 psi up to 29,000 feet and 7.33 psi between 29,000 feet and 33,000 feet. Loss of pressurization is detected by a pressure switch in the cabin. This is indicated by the red Cabin High Altitude Annunciator on the central warning panel when the cabin altitude exceeds 9,300 feet. A ground pressurization switch on the ground test panel allows ground functioning of the pressurization control system. When pressed, an integral warning light illuminates. The weight on wheel switch is overridden and the discharge valves may be closed. External checks. The condition of the front and rear discharge valves should be checked. Pre-flight. After AC power has been applied to the aircraft buzz bars, the ground pressurization button on the ground test panel should be pressed to test the filament. The button should be pressed again to disable the ground test facility. The pressure controller is now checked. The discharge valve selector should be checked in the detented normal position. The manual rotary control should be set to the mid position. This ensures that a stable cabin altitude is maintained if the manual mode is selected during flight. The rate control should be checked in the detent. This will give a cabin climb rate of approximately 550 feet per minute. The mode controller should be confirmed in the auto position. When APU air is selected on, the discharge valves will open as they are provided with controlling air. Standard pressure setting must be selected using the baro control and the intended cruise level set using the alt control. For systems with a maximum operating altitude of 31,000 feet, the intended cruise level should be set up to 28,000 feet. Above 28,000 feet, a cabin altitude of 8,000 feet should be set. This procedure will give a cabin differential pressure of 6.35 psi at cruise altitude. For systems with a maximum operating altitude of 33,000 feet, the intended cruise altitude should be set. With this system, a differential pressure of 6.97 psi will be maintained up to 29,000 feet. Between 29,000 feet and 33,000 feet, the differential pressure of 7.12 psi will be maintained. The condition of the triple gauge should be checked. Alt should indicate pressure altitude, and the rate and differential should be 0. In flight. To minimize pressure surges on takeoff with auto selected, the discharge valves are signaled to partially close when the number 2 thrust lever is advanced to a takeoff setting. This action pressurizes the cabin to a maximum of 400 feet below airfield level. Normal automatic control resumes when liftoff occurs. The pressurization system should be checked periodically during flight for correct operation. Shortly before commencing descent, the destination QNH and the destination airfield threshold elevation should be set on the pressure controller. The rate controller should be confirmed in the detent. This will give a descent rate of approximately 350 feet per minute. Upon landing or following a rejected takeoff, the discharge valves are fully opened with weight on wheels and the number 2 thrust lever retarded. This ensures that the cabin is fully depressurized. Loss of cabin pressure. Loss of cabin pressure is indicated by cabin high altitude. If the air conditioning packs were selected to recirc, they will automatically revert to fresh to supply more air to the cabin. At what cabin altitude does cabin high altitude illuminate? Following loss of cabin pressure, the mode control must be set to manual and the discharge valve set to shut. Cabin pressure should now be under control as both discharge valves have been manually shut. To confirm this, the cabin altitude and rate of climb should be checked. If control cannot be regained, an emergency descent should be considered. Any pressurization abnormality. If any pressurization abnormality is identified, manual mode must be selected and the discharge valve selected as required. If control is regained, the required rate of cabin climb or descent should be set by opening or closing the discharge valves, with reference to the indicated rate on the triple gauge and not the discharge valve position. As the valves are no longer actively controlling cabin altitude, cabin rate of change will vary with engine N2 and aircraft altitude. Cabin altitude and aircraft altitude should be equalized shortly before landing, and the discharge valves then selected fully open to ensure that the cabin is fully depressurized on landing. Automatic cabin depressurization via the squat switches is not available in the manual mode. If the failure is apparent as a cabin overpressure, the air conditioning pack should be selected off as required to control the pressure. If the failure is apparent as a cabin under pressure, the first action is to divert more air into the cabin by selecting Cabin Air to Fresh. Before landing, both packs must be selected off, and the discharge valve selector switch set to Ditch, to ensure that the cabin is depressurized on the ground. (31,000 feet version). The maximum normal pressure differential up to 30,000 feet is 6.55 psi. Above 30,000 feet, the maximum differential pressure is 6.75 psi. The cabin must be at zero differential pressure commencing takeoff and during landing. (33,000 feet version). The maximum normal pressure differential up to 29,000 feet is 7.32 psi. Above 29,000 feet, the maximum differential pressure is 7.46 psi. The cabin must be at zero differential pressure commencing takeoff and during landing.